I'm going to prove that for every positive number a, that e to the a is equal to the limit of this sequence as n goes to infinity. Now, I've reverse engineered this proof a little bit using a proof in our textbook. So if some of the steps I'm doing at first seem mysterious, just try to make sure you're following each step individually, and you'll see how the result magically pops out. So I'm starting with this piece of knowledge, that if f of x is equal to ln x, then the derivative of ln x is equal to 1 over x. And what this means is, when I plug in 1 over a into the derivative formula, I get just a. That's one of those mysterious things. But here's how I'm going to use that. I'm going to use the definition of derivative here. So f prime of 1 over a is equal to this limit, the limit of the difference quotient with 1 over a. Next, I'm going to substitute what I know about f. F of x is ln of x. So I change the f's into ln's. And next, I'm going to do a bit of algebra. So I have here the difference of two logs, and so I can use this log property, ln a minus ln b is equal to ln of a divided by b. I did a second thing too, or at least I'm going to. C times ln a is equal to ln of a to the c power. So now that I have taken my difference and turned it into a quotient, I'm going to rewrite my expression this way. I did two things here. I took this 1 over a in the denominator and I flipped it and multiplied so that the expression on the inside turned into 1 plus a times h. And I took this coefficient here, 1 over h, and I moved it to be an exponent. So here I am. I know that a is equal to the limit of this expression. I have two more steps that I need to do. The first thing I'm going to do is set n equal to 1 over h. I'm going to reparameterize. As h goes to 0, 1 over h is going to get really, really large. So it's the same thing as n going to infinity. And this allows me to rewrite my limit this way. The limit as n goes to infinity of ln 1 plus a over n to the n power. That's one step. The second step is to do a computation, a simplification of e to the a power. So I'm ready for the punchline. So first, I substitute what I know a to be. I did all that work. I'm going to substitute that now. And next, I'm going to use the property that e to the x is a continuous function. And what that means is this and this are allowed to change places. You can do that when you're dealing with continuous functions. Next, the e and the ln cancel, and you're left with the limit as n goes to infinity of 1 plus a over n to the n power.